So hi, so today we are going to see our next question, that is question number 217, contains duplicate. So basically in this question we have to determine whether in the given array there are duplicates present or not. So we have given an integer array nums and we have to return true if the value appears at least twice in the array and return false if every element is distinct. So let's see an example. So in the input we have given an nums array and this nums array contains the value 1, 2, 3 and 1. So here 1 present twice, so this contains duplicates. And here another example, in nums array 1, 2, 3, 4 are the presented and there are no elements repeated, that means in this array there is no duplicates present, hence we return false. So let's see our first approach, that is the brute force approach. In this approach the first step is for each element at index I from 0 to n minus 1 we are again going to iterate in this loop, and for each loop at index j from I plus 1 to n minus 1, then we are checking if nums of I is equal to nums of j. If it is equal to, that means we have duplicate element, then we return true, and if not, after completion of this for loop we are coming to this second condition, we returning false. Let's see an example. So we have a nums array which contains the values of 1, 2, 3, 1. So let's see first approach. For each element at index I from 0 to n minus 1, that means I is here, I is equal to 0. Then again for each element at index j from I plus 1, that means here is our I and I plus 1, that means here j. J is I is 0, then j is I plus 1, that means 1. If nums of I is equal to nums of j, nums of I or j are not equal to, then we again going to increment this j. Now j becomes 2 and j comes here j. Then again we are checking where this and this I or j is equal to or not. Again these are not equal to, then again we are going to increment j, and this time our I and j are equal to, that means we are going to return true. So hence we found duplicate elements in the array, and that's why we are going to return true. And because of two nested loops, the time complexity of this approach is order of n square. So we see the brute force approach, but this brute force approach uses the time complexity of order of n square, and because of this it is only useful for small length arrays, and if array length is big then it exceeds time limit, so this approach is not more practical. That's why we are using our next approach, the sorting plus adjacent check algorithm. So let's see our second approach, that is sort plus adjacent check. So in this approach we firstly sort the array and then check our adjacent elements are duplicate or not. If duplicate, then we return true, or if not, then we return false. So in the first step we are going to sort the array, and in the second step we are running a for loop from I is equal to 0 to length minus 2, and each iteration of this for loop we are checking whether our nums of I is equal to nums of I plus 1 or not. If these are equal, then we return true, and if not equal to, then we are again going to run a for loop up to length minus 2, and if we didn't find duplicate element, we come out of this for loop, and in the last step we are returning false, that means we didn't find any duplicate element. So let's see an example of this approach. So we have nums array which contains values 1, 2, 3, 2. So in the first step sort the array. So after sorting our array, it becomes like 1, 2, 2, 3. In the second step, we are running for loop from I is equal to 0 to length minus 2. From I is equal to 0, so here is our I is equal to 0. Then if checking whether our nums of I is equal to nums of I plus 1. Here nums of I is 1 and nums of I plus 1, that means 2. Is this equal to not? Then again we are going to increment I, and after that we again checks whether nums of I is equal to nums of I plus 1. Nums of I is equal to 2 and nums of I plus 1 is equal to, and both are equal, that means we are found our duplicate elements. So we return true that our array contains duplicate elements. And this approach has the time complexity which is equal to the time complexity of the sorting algorithm for this array. So let's see code of this. So let's see our next approach, that is sorting plus adjacent check. So in this approach we first sort our array, and for sorting we are using inbuilt array sorting method. So for this arrays dot sort and our nums array, then we are going to run a for loop from I is equal to 0 to length minus 2. So let's run it, a for loop from 0 to length minus 2, that means nums dot length minus 1. And in this for loop we are checking whether our two adjacent element have same value or not. If same value, we find duplicate element, and if not, we didn't find any duplicate element. So let's check it. If nums of I is equal to our nums of I plus 1, if they are equal, then we are going to return true, and if not, then we are going to return false. So let's run it. Let's submit this code, and we have successfully submitted this code. And so this approach uses the time complexity by which we are going to sort our array, and here we are sort the array by inbuilt sorting method, and this inbuilt sorting algorithm uses the time complexity of order of n log n,